Now in the interface circuit, in the last class we discussed parallel port for the input interface. Now we are going to discuss parallel port with the output interface. Now here we have connected the output device to the output interface circuit. Now parallel port means what? Data will travel parallelly. At a time, complete data will go to the printer circuit. Now here asynchronous bus protocol is taking place. That's why master ready, slave ready signals are used. By using these two signals, data transfer takes place between the processor and the interface circuit. And here if you see, this is the interface circuit. In this interface circuit, we have a data out register and also one flag register. In that flag register, one of the bit is S out bit, status out bit. Now by using the valid and idle bits, the data transfer takes place between interface to the printer. Now how the data transfer is taking place, that we try to analyze by using this diagram. Now if the printer want to print the character, now one more analysis is what? In the last class only we have discussed that. So here the address bits are how many bits? 32 bit address. For a circuit analysis we are using that. Okay. Now if the printer want to print character, then first the printer sends the idle signal to the interface. Thereby if the data out register is full, then S out bit is equal to 1 and it will send the valid signal to the printer and also keeps the data on the data bus. Thereby printer prints the character. Now if the printer want to print the second character, then it will send the idle signal to the interface. But at the time what? Previously the data is placed on the data bus. So now that data register is empty, it is cleared. So thereby S out bit is equal to 0. So now processor should send the data to the, load the data into the data register. So for that, now first processor will read the status of this interface by reading this S out bit. If this S out bit is equal to 0, then processor understands that data out register is empty. Thereby it will load the content into the data out register. Now for that, first it will place the address of the status register. Now which address? First it will place the status register address and it will send the read command. And after decoding this address or with some propagation delay, a master ready signal is sent to the interface circuit. After receiving the master ready signal, now the interface will send the slave ready signal to the processor. Thereby, along with the slave ready signal, now interface will place the status bits onto the data bus. So processor will read the status and it will understand S is equal to 0 means what? Register is empty. Thereby processor will place the data onto the data bus and address onto the address bus. Now this time which address? Output register. Now data out register address it will place. And also it will place the write operation. Now it is sending the data into the interface means what? It will send the write command. So now this bit is equal to 0. And after some propagation delay or after decoding the address bit, it will send the master ready signal. After receiving the master ready signal, now the interface will send the slave ready signal and also copies the data into the data out register. Thereby S0 bit is equal to 1. So if the data out register is full means what? S out bit is equal to 1. This makes the valid signal enabled. Thereby what? It will place the data onto the data bus and the printer prints the second character. Now this is how the processor is sending the data to the printer. The same analysis we will try to do using the circuit diagram. Now this is the output interface circuit diagram. It is almost like an input interface circuit diagram. Now here you can see that idle. If the printer want to print the character, it will send the idle. If the load this bit is equal to 1, then it will send the valid bit to the processor, and also whatever the data is in this register, that is enabled, because if this bit is 1 means what? This is enabled and that will be placed onto the printer data bus. So printer will print the character. If the now once the data is placed means what? This is disabled. So now if the printer want to print the second character, so it will place the idle signal, but at the time valid bit is equal to 0, that time processor should send the data to the data output register. For that, processor first reads the status register. For that, it will place the 32-bit address on this. In that, 31 bits will be decoded by the address decoder. If this address is matching with the printer address, this interface address, now it will generate one. Now this address will go to the all the interfaces, but remaining interfaces will addresses will not match with it. That time in the other interfaces, the bit is 0. Now only particular this interface, this bit is equal to 1. Now, by checking the last bit, if this bit is equal to 0 means what? It will read the status. If this bit is equal to 1 means what? It will enable the data load. This become 1. So thereby it will place the data onto this data register. Now first it will read the status. How it will, we will check. Now it will place the 0 here. So total 32 bits it will place, 31 bits are enabled. So it will place the 1. With this 0, this bit become 1. With this 0, this become 0. Means what? This is disabled. It is low only. Now it will place the read signal because status processor is reading the status. So it will place the read signal. And after decoding the data, it will place the master ready signal. So all the bits are 1. Thereby it will select the 1. So if this is 1 means what? So this read status is 1, this is 0. Any one of the bit is 1 means what? Or get output 1. This enables the slave ready signal. After receiving the master ready, it will send the slave ready to the processor. So and also it will place the data status register. This bit is what? Once the data is placed means SOut bit becomes 0. So that 0 bit, it will read the whatever the data is present on this, that is nothing but a status register content. It will processor read and it will understand the SOut bit is equal to 0. So processor now after reading the SOut bit is 0, now processor will place the data next character onto this data bus and also place the address on this address bus and also place the write command on this line. So after decoding the last 31 bits, now this bit become 1. Now the first lower bit is what? Now this address is nothing but address of the data out register. So now this bit become 1. So with this bit makes this bit as a 0 and here it makes 1. And because this 0 also, this bit becomes 0 and here it is 1. So it is enabling the data load data bit. So thereby what? It will send the valid signal to the printer and also it is enabling the data output register. Thereby whatever the data is present on the bus, that will be loaded, and also because of the idle signal, if the idle signal is enabled, so valid signal is also forwarded to the printer, and also this whatever the data is loaded, that is also kept on the printer data bus. Thereby printer prints the second character. Now this is the analysis of the output interface. Now we will see the combined circuit for both input interface and output interface. Now here if you see data and register. Now here input interface is input device is connected. For the data output device is connected. And here if you see SIN bit, S0 bit means what? Both the bits are in the same register. So already I said that flag register, status register is a combination of 8 bits. One of the bit is SIN bit and the second bit is what? SOut bit. Now whenever the processor want to read the input, so it will read the status bit and it will check the input flag. And whenever wanted to see the output register, processor reads the status register and it will check the output register flag. So thereby if the processor want to send the data, it will place the data, place the address, and data goes to the output register. Processor want to read the data means what? It will enable the data in register by enabling this this is a tri-state buffer by enabling this AND gate. So whatever the data is there, that is placed onto the data bus. So processor will read the data. Now for this what? To enable the this buffer or to enable the data out register or to read the status register, it needs the 3 addresses. So for that what? Now among the 32 bits, 30 bits are applied to the decoder and the last 2 bits are used to read the status register, read the I enable the data in register and data out register. So 3 addresses are required. So A0 and A1 bits, if I'm taking 2 bits means what are the combinations? 00, 01, 10, 11. So among these 4 combinations, 3 combinations are used to read the status, enable the data in, enable the data out. The remaining analysis is same like a input and output, how we have done the analysis. So same, use apply 0 0 here, 0 1 here, 1 1 here, 1. These four combinations you apply and see that how these AND gates are, outputs are become one, and how the slave ready signal is sent to the processor, and which buffer register or data in register, data out register, how it is enabled, you analyze. Okay, the remaining processing. So instead of this circuit, we can also analyze the same diagram. This diagram we are trying to analyze with a block. Okay, this is the data in register, data out register. This is the data in buffer register. This is data out buffer register. Direction means what? Whenever the processor want to read the data, this will enable this buffer register. If the processor want to send the data to the output register, then this direction will enable this buffer. So this is nothing but what? Now these AND gates are there. These AND gates are inside this direction register. So depending upon which AND gate is enabled, it will enable this buffers. Now coming to the my address, here 30 bits are applied to the decoder, and the 3 bits are used to select any one of the, now here data out register, data in register, and status register. By using this for A0 and A1, by using these two, these 3 bits are generated, and these 3 bits will select any one of these register. And the read write means what? Processor want to read means it will send the read signal, write means it will send the write signal. Accept and ready means what? These are nothing but a handshaking signal. Whenever the processor is ready to send, it will send the ready signal. If the devices are ready to accept, then it will send the accept signal. Now here you can see the interrupt signal. Instead of polling, whenever the devices are ready to transfer the data, then it will send the interrupt signal to the processor. That time processor will do another job. Whenever it receives the interrupt signal, it stop executing the current program, and it will transfer the data to the IO devices. Now here, this is the analysis of the both input and output circuits. Now with this, parallel port is done.